Hey, Sammy. I hope you're doing well. I read your question, and I'm happy to give you a hand with it. Basically, this is nothing more than an energy conversion problem. And what's happening is the energy that is being produced in the spring in the pogo stick is going to be transferred to the pogo stick and the man, the combined mass, and then the man and the pogo stick will reach their max height when the potential energy goes to zero. Okay, so this is really nothing more than converting the energy of the spring to the potential energy of the person or the man and pogo stick, which would be the total mass, which would be the mass of the man plus the mass of the pogo stick times the gravitational pull and times h. Okay, so basically what happens is the energy in the spring gets converted to kinetic energy for these two guys, and then that kinetic energy goes to zero when we reach this height. And as a consequence, the equation that you need to solve is just simply the energy in the spring, and we need to set that equal to the combined mass of the man plus mass of the pogo stick times g times h, and all you have to do is solve for h. And then h will be equal to k. That's a lousy k. Let me try that again. K x squared divided by 2 times the sum of the masses times GH. That's it. All right, so plug and solve. We have that K is 25,000. X is going to be 0.4. I'm going to square that. And then we have 2. The combined masses is going to be 75 plus 5 kilograms. Not minus, but times. So that's 80. And then we can use 10 for G. Oh, and actually, there's no H here. What am I thinking? It's getting too late at night. I should be going to bed. Okay, and there we go. And of course, then this is equal to H. It turns out that the numerator comes down to 4,000. 25,000 times 0.16 is 4,000. Trust me. And the denominator comes down to 1,600. And the answer is 2.5. And it'll be 2.5 meters. And if you think about it, this is kind of like one of those, the potential energy problem and kinetic energy problem in reverse. Because remember, in probably one of your classes, you have one of those, they talk about one of those scenarios where you have an object a certain weight at a certain height. And you know that, or of a certain mass at a certain height, and you know that potential energy is mgh, and if you let it fall, when it falls down to that, when it falls down to that height, then we know that mgh is going to be equal to the kinetic energy. Well, here we have a spring, basically a spring. And it's going to, but that's compressed, and it's going to propel a mass. And when that spring decompresses and comes up here, which is basically that distance x, well, then we know that all the potential energy in that spring, which is 1/2 kx squared, is going to be converted to kinetic energy, which is 1/2 mv squared. So here we have a thing moving at 1/2 mv squared in the presence of gravity. And what happens is that kinetic energy deletes and deletes and deletes until it all becomes potential energy, which occurs at mgh. So basically we have these two equations that govern. This equation governs this equation governs the potential energy of the spring being converted into kinetic energy. And then this equation, this equation governs the conversion of all that kinetic energy back to potential energy at a height h. So it's really nothing more than it's really nothing more than a combination of these two problems and the idea of looking at potential energy and kinetic energy in reverse. Anyways, I hope you found this useful, and I hope the explanation makes sense. And again, if you need any help, I'm happy to lend a hand or two, and hopefully next time will be a tad more coherent. Thanks, and hope you have a good evening.